WaterSense, as an example, is trying to figure out how to waste the least water in the delivery of hot water from the water heater to the fixtures. Fair enough? They also don't want to do anything inadvertently screwy with energy use. You don't want to increase energy use by a factor of 100. That would be pretty silly too, to save the water. Math doesn't pencil out smart. So the trick is to balance that equation in somewhere in the middle. Fair enough? All right, let's keep going. Let's give everybody a hand. Take all the pipe and put it back over here in the corner, please. Give everyone a big hand. All right, let's keep going here. And the answer is a cup. So then the question is, how do you improve the delivery phase? Remember, there's 3 phases. To improve the delivery phase, you've got to reduce the volume of the water in the pipe from the source of hot water to the fixture. There is no other way. Everyone got it? I've been looking for 18 years. There is no other way to do it. You have to reduce the restrictions to flow. Standard 90-degree elbows are out. You want really wide sweeps. That's where we're going with this discussion. You want to increase the flow rate before you turn on the tap, right? You'd like it to move really quick from the water heater to the point in question and shut off. That would be good. And you want to insulate the pipe. Even in the delivery phase, it matters when you're going through really cold environments. Imagine underground between one building and another building on a campus. And by the way, it rained. And there's water down there now. It's really cold. Bad choice. So here's a table that talks about the length of pipe that holds 8 ounces of water. 1 cup. And it shows the major types that we're used to. And what I'd like to do is everyone look at the average, because we're going to use the average numbers for the exercise we're going to do in a minute or two here. 1/2-inch diameter pipe, which is the legal minimum we're allowed to use right now, is how many feet? 5 feet. And 3/4 inch is 2.5. And 1 inch, if we need it, is 1.5 feet. Does that make sense to everybody? Just remember those numbers. Some people talk about time. You all talked about time before. If you want to deliver hot water within 3 seconds, you had better remember your flow rate. I think that the magic number for measuring time needs to be 1/2 gallon per minute, because I think that all lav faucets are headed there in the next 10 years. We know how to build good lav faucets for commercial purposes that are 1/2 GPM per minute. Why not use that same technology in residential? Fundamentally, I don't see a reason why not to use it. And if that's the case, we'd better make sure our systems perform at 1/2 GPM. But what's the standard flow rate for a kitchen faucet today? 2.2 at 60 PSI, right? Well, imagine you design a system that works 5 seconds at 2 gallons per minute, and you now drop it to 1/2 gallon per minute. Your time just went up by a factor of 4. If you set a standard, which is something that's being discussed for WaterSense and other programs, at 15 seconds, I'll tell you, people don't like to wait a minute to get hot water. We'd better think the future now. We know enough to think about how to do it now, and we should do it. All right. To improve the use phase, you got to insulate the pipes. How much? Minimum R4, which is typically, for the diameters we're talking about, 1/2-inch to 3/4 inch diameter. Okay? And for the cool down phase, insulate the pipes. What works for the use phase works for the cool down phase. Same stuff. All right. Now, we're going to hold off the slides. I need more volunteers, new volunteers this time. Come on, I need volunteers. I need about 5 people. Come on up. Promises to be fun. All right, if you look carefully around us here, on the floor you'll see some tape. All right? The tape is representatives of the plumbing rooms in a fairly typical US home. All right? Over here we have the laundry room. What do you see here? Isn't that the washer? That's a marking for the washing machine. Dryer would be next to it. I put it on an inside wall rather than an outside wall, because you're not supposed to put plumbing on outside walls in some parts of the US, right? All right. Over here is the spot for the refrigerator, and here's the kitchen counter. By the way, there's a window right here. There's always a window right over the, right? We're going to have a window right there. And there's the kitchen sink, and there's the dishwasher. All right. Now we're going to go down the hall. It's not a very long hall in this case. And we're going to go over here to the back-to-back bathrooms. There's a sink in each bathroom, a toilet in each bathroom. Doesn't get hot water yet. And over here is a tub shower combo and a master shower. Anybody ever seen a house like this before? Anybody live in one like this? It's representative of over a third of the U.S. housing stock, from floor plan sizes on the order of 1,000 to 3,000 square feet. All that happens in bigger homes is that the things get spread out further. Fair enough? This could be upstairs and downstairs. It could be on the same floor. Pipe's pipe, distance is distance. Fundamentally, doesn't really matter at the moment. What we're going to do is to pipe this house using tape for our pipe. Fair enough? So the first question you have to ask is, where's the water heater going to go? You guys decide. Where do you want to put the water heater? No, you can put the water heater anywhere you want. But we've got to decide where we're going to put the water heater because it isn't in here yet. Anybody ever showed up the job? Where are you going to put the water heater? Okay. By law, right. In the corner as far as you can get is the way the law must be read because that's where it always gets put, right? So the first question you really need to ask is, do you have a basement? How many here live in a house with a basement? How many here live in a house without a basement? Guess where people are moving to? Places where people don't get basements. Okay? For the most part, the South and the West don't do basements. All right? So the question is a basement, a crawl space, or a slab-on-grade construction? Which one are we going to pick for today's example? Slab-on-grade, is that okay? We'll discuss the options in a minute. If it's slab-on-grade, I already know where the water heater goes. In the garage. Oh, in Houston, it goes in the attic, yeah, which is really dumb. Why would you put something that's going to leak over your head? I'm confused by this. I like it. I like it. All right, so let's mark the spot for our water heater. And here you go. Put an X right outside the wall there in the garage, okay? X will mark the spot. Now we're going to think about plumbing the house. Anybody up here do plumbing? Anybody? You do plumbing design, I know this. All right, so here you go. And here we have, anybody know the plumbing code? Come on up. You volunteered? Huh? Someone here better know the plumbing code or everyone's in trouble. All right? Pick. You got to pick the IAPMO code.
For this purpose, they're all good. IAPMO works.
IAPMO works. So what I have here are fixture units. And every one of those cards has fixture units on it. So we have to decide, before we decide on the diameter of pipe we're going to use, we got to know the fixture units. So we're standing in the bathroom here. What's the fixture unit for a typical sink? It's 1.
How much flow?
I look on the code. I'm not calculating much. What am I going to pick? There's a 1 in there.
Let's assume a 1.
There's a 1 in there somewhere. You'll find it. I'll take these guys. Get them out of your way and make your life easier. You've got 2s. You've got 4s. You've got 3s. There must be 1s in there. I know there are 1s in there. Put a 1 on each sink. Great. Toilet we're going to ignore for now. It's not hot water. Okay? We're in the master shower. Is there 1 shower head or 2?
6.
Cool. This is an older home, hasn't been renovated yet. It's going to become 6. That's another problem. Actually, it's get a 2. It gets a 2.
It's 1 shower head.
1 shower head, so it gets a 2. This is a tub shower combo. What does it get?
Same thing, 2.
1.
4.
4. Cool. Pick up cards. So about a year ago, I was in Wisconsin. I was in 3 different towns on 3 different days. They have 1 code in Wisconsin. It got 3 different answers in each town. 1 answer in each town. It was great. We'll pick a 4 there if you can. Yeah, it's there somewhere. Let's move over here while he's thinking. There must be a 4. Got a 4? Let me take a 2. Oh, no, we're good. All right, I'll need another 4, by the way. All right. What about the kitchen sink and the dishwasher? What do they get? I think they get 1.5 each or a combination of 3, right? So here's the 1.5s. Put 1 on each of them, right? I'll put 1 over here. All right. Now, what's the washing machine get?
3.
3 or 4?
3 or 4, depending on 4.
Yeah, pick a 4. Last time I read the code, it all said 4. But you know what? It keeps changing. And it depends on the local jurisdiction, doesn't it? All these answers vary all over the place.
People like you that keep changing.
Well, I don't do that much anymore, do I? All right, we can put these down and just relax on this stuff.